Also, as a warning, yes, this is very important, but you will need to know how to do hypothesis testing using both methods, p-values and rejection regions. And understand that if they're asking you for critical values, that they're asking you for the values that create your rejection region. If they're asking for a test statistic, that's that Z value in this case that pops out of your calculator, that you're deciding whether or not that falls in your rejection region. So let's do one more at least of these hypothesis testing problems. And again, we're going to do them both ways to make sure that we have this down pat. So let's start with this next one by starting with the claim. Always. So I'm going to read this question, but I'm only looking for the claim. In a presidential election, 308 out of 611 voters surveyed said that they voted for the candidate who won. Use a 0.01 significance level to test the, here it is, claim that among all voters, the percentage of people who believe they voted for the winning candidate is equal to 43%. So remember, when we're translating our claim, we have to decide whether or not we're dealing with a p, mu, or sigma. What inequality we have, less than or equal to, greater than or equal to, not equal to, less than or greater than, and then what our value is, at least to start. Well, again, we're dealing with a percentage or a probability, so we're going to be starting out with a p in our claim. And then the next thing, they actually told us what symbol they said is equal to, so we're going to be using the equal to. Equal to what value? 43%. Again, we got to turn that into a decimal, so 0.43. So our claim is that our p is equal to 0.43. So where is that going to land? Is it going to fall as our h naught or our h1? Well, because of the equal to, it's going to fall in. Whenever there's an equal to, it's going to fall in as our h naught, our null hypothesis, so p equals 0.43. And I'm going to put a little C for claim next to it. What does that mean about my h1? Well, it's the complement or opposite, which means it'll be p is not equal to the 0.43. So that at least gets us set up, though. Now, what does this mean? Remember that because we have a not equal to now, this is going to mean that we're going to have a two-tailed picture. So that will kind of be happening behind the scenes. We're going to be doing this using the p-values approach first, but the setup would have been the same no matter what so far. We would have been doing the same thing had we been doing rejection regions. So let's continue along. So continuing along, the next thing that we'd say is, okay, well, we need to run our one prop Z test. And what it's going to ask for is our P naught, our X, our N, and a symbol to choose from, either not equal to, less than, or greater than, and then we'll go ahead and choose calculate at the end. As a reminder, how do you get to the screen? Remember, you choose stat option, and you arrow over to the right twice to test, and then scroll down to, I believe it's option 5. So, our P naught, remember, that's going to come from the 0 should remind you from the null hypothesis, which is the 0.43. So, I'm going to go ahead and fill that in. Our probability from the P naught is 0.43. The next thing that we need to come up with is our X and our N. That's going to come from our P hat. Our probability from our p hat, which is from our sample, which is the 308 out of 611. So our x over n is a 308 over 611. So our x is 308, our n is 611. And remember, the last part comes from our h1. And what symbol is on our h1, which is the not equal to, which is going to tell our calculator to do a two-tailed test when we go down to calculate. So let's see what this would look like in our calculator. Continuing along, our calculator would look something like the following. Exactly the way I had it written out. And then you go choose your calculate option at the bottom. I know you can't see it here, but it's right here. And then once you did, we're doing the p-values approach, so we're going to use the p-value. I want you to look at the whole number. I see a 2.16, a bunch of other numbers, an E, and a -4. Remember, that means it is in scientific notation. So that means we're actually looking at a p-value equal to 2.16 times 10 to the -4th. Remember, that means you've got to move your decimal place 4 places to the left to actually figure out what this number is. So 2.16, and we've got to move the decimal place 4 places to the left to figure out what that is. 1, 2, 3, 4. So that means 1, 2, 3 slots get filled in with zeros. So that means our p-value is actually 0.000216. Question is, what does that mean? Well, that means for my picture, it means that the area between both tails from the test statistic is going to be this 0.000216. Why did I say between both tails? Why did I draw 2 tails? Was, remember when I said my H1, remember when I said my H1 had a not equal to, that meant I had a 2-tailed picture. It means not the middle, the ends. So if I wanted to figure out what each of these tails is individually, I could take the 0.000216 and divide it by 2. That would give you each tail separately. We don't need that though. We want the full p-value, which is both tails together. Now the question is, what do I do with the p-value once I have it? For the p-values method, once you have your p-value, you always ask the same question. And it is p less than or equal to alpha? Well, our p we just got was 0.000216, and our alpha was given to us in the original problem. It was 0.01 was our significance level. Remember that alpha is your significance level that's given to you in your problem. So is the 0.000216 for the p-value that we came up with, is that less than the 0.01 that we got for the alpha, the significance level that was given to us? Yes, absolutely. What does yes mean? It means that we're going to reject H0. Because we're rejecting H0, we need to figure out what's going on and where's our claim and where's everything. So let's go back to the beginning and we can figure out what our H0 and our H1 is so that we can come up with our final statement and everything. So let's see. Our H0 was P equals 0.43, and this was actually our claim, just recopying this back from the beginning. And our H1 was that P doesn't equal 0.43. And let's see, we care about which of the two. We care about which one our claim is, which is our H0, which happens to be what we are rejecting. H0. So I'm going to write reject next to that. So that means we're actually going to do something here. So when we actually write out our final sentence, it's going to be that there is sufficient evidence, because we're doing something, not failing to do something. Sufficient evidence to, what are we doing? Reject and the claim. And notice we get this answer when we actually redo the same exact problem using rejection regions. We're going to get the exact same answer. We're just going to